In how many of distinct permutations of the letters in Mississippi do the four I's not come together? So we have studied about bijection rule, where if we want to calculate the favorable ways, we can calculate it like this: total minus unfavorable. So what I'm going to do is I'll put these four I's together and find the number of arrangements and subtract them from the total number of arrangements. To find the number of arrangements when four I's do not come together, right? So what is the total number of arrangements? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial divided by how many I's are there? 1, 2, 3, 4 I's. So I'll have to divide it with 4 factorial because these are alike, right? And now let us focus on S. 1, 2, 3, 4 S are present. So I'll divide it with another 4 factorial. Now let us see if there is any other that are alike. P. So 2 factorial, and that's it. So these are the total number of permutations of these letters in Mississippi. Now when 4 I's come together, so let me put 4 I's together as one unit. When these are put together, I am treating them as one unit. So rest of the 7 letters are 7 other units, right? So in total I have got 8 letters now because I am treating this as one, right? So the total number of permutations will be 8 factorial divided by, now I's I have put here, I am treating them as one unit, but still 4 S are there in these. So let me divide it with 4 factorial. And what about P's? 2 P's are there, so I'll divide it with 2 factorial. So these many number of arrangements will be there when I's are together. I don't have to multiply it with the number of arrangements that among these, because these are all I's, so they can be arranged only in one way, that is this way, right? So I don't have to multiply it with anything. So this is the total number of arrangements when 4 I's are together, so I have to subtract this from the total. So this will be my answer. Now I'll leave the calculation to you, but let me simplify it a little bit. So 4 factorial, 2 factorial I can take as common. Here I'll have 11 into 10 into 9 divided by 4 factorial minus, this will be 1, right? And what else? 4 factorial can be written as 4 into 3 into 2 into 1. So this 3 will give me 3 here, 2, 5, right? So I leave the rest of the calculation to you. Alright, there will be this big number, but this is how you will calculate this number. So there was only one part to this problem. Yes, that is done. Let us look at the last question of this exercise. In how many ways can the letters of the word permutations be arranged if words start with P and end with S? So the first part is the word should start with P, this position is fixed, last position is fixed. How many total letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So out of total 12 letters, 2 letters are fixed at first and last positions. So we have got these 10 positions to be filled. So these can be filled in 10 factorial divided by, let us see if I have got something alike. I have got 2 T's here. So I'll divide it with 2 factorial. What else? M, U, A, and everything else is present only once. So this is the total number of arrangements of these intermediate letters, because P is fixed here, S is fixed here. 10 letters are there in between P and S. These can be arranged in 10 factorial by 2 factorial because 2 T's are there, and you need to reconfirm that something else is not present twice. E is not present, R is present only once, M is present only once. So yes, everything else is present only once. So this is your answer to the first part, 10 factorial by 2 factorial. Let us look at the second part. Vowels are together. Vowels are together. E, U, A, I, O. So 5 vowels are present. Let them be together. So I'll tie them together. A, E, I, O, U. Alright. So I'll treat them as one unit. Total I have 12 letters. Out of these 5 I have tied here. So 7 letters are left. So total units are, 1 unit is this, 7 letters are these. So 8 units are there. So these can be arranged in 8 factorial ways divided by. I have got 2 t's. So I'll divide it with 2 factorial. Now I'll have to multiply with the number of arrangements these letters can be arranged among themselves. So I have to multiply it with 5 factorial. So these are the permutations when vowels are all together. There are always 4 letters between P and S. So let me clear this space. 4 letters between P and S. So these are 12 positions to be filled. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now consider this. If I place P here, then there will be 4 letters, 1, 2, 3, 4 between P and S. Right? And rest of the 10 letters can be arranged in 10 factorial by 2 t's are there, so 2 factorial. These are the number of arrangements. Rest of the 10 letters can be arranged. Now what about positions of P and S? If P is at this position, S will be here. If P comes here, second position, then S will be here, because I have to maintain 4 letters between P and S. If P comes at third position, then S will be here. P, S, P, S. If P comes here, S will be here. P is here, S will be here. There is no other position for P, right? The way I'm going. So 1, 2, 3, 4, 5, 6, 7. So I'll have to multiply this with 7, because these are the arrangements for P and S. Now this can be for S and P also. So I'll have to count it twice, because I have to maintain 4 letters between P and S. So it can be this way also, S, P and then 4 letters. So whatever number of ways I have calculated for P, S, these positions, so I have to double it, because these can be like this also. I hope you have understood. So this is your answer, which is, this will be cancelled, 10 factorial into 7. So this was the exercise 7.3.